Hello class, this is lesson 3-4. Here we will learn rational equations, and then after that we will look at equations involving radicals. Now what a rational equation is basically an equation involving fractions like the one I wrote in this example. Sometimes the variable will be on the bottom of the fraction. And then when we look at radicals, a square root is an example of a radical, or an exponent with a fraction. So anyways, but we'll look at those later. We will begin with rational equations, and I wrote a rational equation in this example. 1/3 minus 18 over 25 z equals 8 over 25 minus 1 over 15 z. So the goal is to solve for z, but in this case it's on the bottom, and we're subtracting fractions, and when we add or subtract fractions, we do need a common denominator or a common bottom, which we do not have. So the idea here is to multiply numbers to the top and bottom of each fraction so that we do have a common denominator, and then once we have a common denominator, we can just crunch this all into one term and easily solve it. Okay, so let's look at this fraction here, 1/3. Well, what can we do to make it common with this bottom here? We want the bottom of these two fractions to be the same number. Well, it's pretty easy. I mean, we could just multiply 25z to the top and bottom of this guy here, right? And then multiply 3 to the top and bottom of this guy. And now we have the same bottom. We have a common denominator. Okay, so the left-hand side is now 25z on top over, 75 z minus, let's see, so we have 18 times 3, which is 54 over 75z. Okay, so now the left-hand side has a common denominator. Let's get a common denominator over here. It's good if we use the same common denominator, so I'm going to multiply 3z to the top and bottom of this. Okay, now we have a 15z here. So if we multiply 5 to the top and bottom of this, that will give us the 75z we want on the bottom, so that everything will have a common denominator. Okay, so the left-hand side is 25z minus 54. And since it has a common denominator, I could put it as one term. Okay, now we will have 8 times 3z here, 24z minus 5 all over 75z. Okay, so this is the goal when we're dealing with rational equations. We want a common denominator. We want everything on the bottom to be the exact same. And once everything is the same on the bottom, you can crunch it into one term. So now that these terms have a common denominator, I can put them on the same side of the equal sign. So we have 25z minus 54 over 75z, and I could minus the other term to the same side here. Okay, I just put everything on one side of the equal sign. I just took this and minused it to the other side of the equation. That's all I did in this step. But now, since we have a common denominator, we could just write this as one big fraction. Right, so we have the 25z minus 54, and then minus the 24z plus 5. Right, so minus 24z, and then a double negative gives us the plus 5. Okay? Now let's just simplify the top of this fraction. We have 25z minus 24z, which just is 1z. We have negative 54 plus 5, so that's 5 minus 54, negative 49. Okay, all over 75z. Okay, so now the equation is pretty easy to solve. What do we do here? Well, we have a z on the bottom and a z on the top, and the whole thing equals 0. Okay, so let's just think about that. We're never allowed to divide by 0, so there's no way this will give us the 0 that we have on the right-hand side. Right? In fact, since we have z on the bottom, we actually know that 0 is not in the domain, because we cannot plug in a 0 here, or else we would be dividing by 0. So I'm just going to make that side note here. That's really all the bottom tells us, is the domain restriction. This doesn't help us solve the equation at all. It just kind of gives us the domain. Really, the top is what gives us the solution. Okay, so the top solution is z equals 49, right? Because if we plug in 49, we get 49 minus 49, which does equal 0. So you just set the top equal to 0 and you solve. Right, so maybe I will do that again here. So what I said was, the bottom does not give us a solution, it just tells us the domain. So what we do is we take the top part of the fraction and we solve that. So when we solve this, we get z equals 49. That is the solution. And it's good to be careful about the domain, because sometimes the solution happens to be the number that is not in the domain. So it's always good to make a side note about the domain, because sometimes you solve the top, you get a number, but then it happens to be that the number is out of the domain, and then there's no solution. That is perfectly possible. But in this case, just the answer is 49, and all the bottom told us is the domain is all numbers z except 0. Okay, so let's look at some more examples of rational equations. Say we have negative 3a over a plus 16 equals 6 over a minus 14. So we want to solve for a. Okay, we need a common denominator, or since we only have two terms, it's basically like the cross multiplication thing you learned in grade school. So when we get the common denominator, or if you want to think about it like cross multiplication, we have the following expression here. Right, so if you cancel out the denominators, or if you cross multiply this out, we end up with this equation here. And now let's just multiply it through. So we have negative 3a squared plus 3 times 14 equals 6a plus 6 times 16. So I'm dealing with a lot of big numbers in this section. Let's see, negative 3a squared, what is 14 times 3? It's 10 times 3, 42. 6a, and then let's see, 16 times 6 would be 96, I think. Okay. And now let's just combine like terms. I'll put everything on the right hand side. So 96 minus the 42 would give us 54. And then let's do, we'll just leave the 6a there. Cool. Okay, so it's a quadratic equation. From the earlier section, we learned the formula, which is negative b plus or minus the square root, b squared minus 4ac all over 2a. So you could do this way or solve, or I just noticed there's another way we could do this. Let's see if we could factor this. Because what we could do is cut all of these by 3, giving us 0 equals a squared is 2a plus 18. Okay, let's see. So can we factor this? Have 9 and 2. Let's see, 3 and 6 doesn't work. Let's see. I don't know, I can't think of a way to factor this, but maybe I'm just not thinking clearly. Let's just proceed with the formula that always works. Sometimes we cannot factor every quadratic equation. Anyways, negative 6 plus or minus square root of 36 minus 4 times 3 times 54, 648 over 6. So 36 minus 648 is negative 612. So yeah, this was not factorable because we will get a complex solution here. Okay, so that's negative 6 plus or minus square root 612 I over 6. Okay, so we get two complex solutions here. Let me double check my work. Okay, yeah. Let's look at another example. Say we have 2 over x plus 1 plus 1 over x minus 1 equals 14 for x squared minus 1. Okay, so again, same idea, we just want common denominators. So there's no common terms with these two fractions, so what I'm going to do is multiply x minus 1 to the top and bottom of this guy, multiply x plus 1 to the top and bottom of this term here. Okay, and when we do that, the top becomes 2x minus 1. Then we multiply the bottom out, giving us x squared minus 1. Okay, and luckily this was cooked up, so the right-hand side already had x minus 1 on the bottom. So now we have a common denominator, and therefore we could put everything into one term. So we have the following. Okay, now again, since this is all just one term, all the bottom tells us is the domain, and now we could just solve the top and get our solution. Okay, so we could make a side note about the domain. X squared minus 1 cannot equal 0 because we cannot divide by 0. So x squared cannot equal 1, therefore x cannot be positive or negative 1. It's just a side note about the domain of this equation. Okay, let's get back to solving this equation. We will solve the top part. So we'll multiply this out, and we have 2x minus 2 plus x plus 1 minus 14. So 3, oh, then this equals 0. So 3x, combine these. Then let's see, negative 16 plus 1 plus 15 equals 0. 3x equals negative 15. Divide both sides by 3. X is negative 5. Okay, now it's always good to check if the solution is in the domain, and in this case we're fine. We just are not allowed to have negative or positive 1 as a solution, but our solution was negative 5, so we are good. Okay, so that's the basic idea with rational equations. We just have an equation involving fractions, and you multiply factors to the top and bottom of each term so that you finally end up with a common denominator. Once you have the common denominator, put everything into one term and then solve the top part. So that is all we have been doing. I will now turn our attention to equations involving radicals. So that will be an equation like this, say square root of x plus 3 plus 4 equals 0. So a radical is something like this, square root, or as I mentioned earlier, it could be a fractional exponent. That's also a radical, just any type of root. Now, the idea, as you may guess, is we need to cancel out the square root. So we could just square both sides of the equation. That would work, but you can be more clever about this. You know, if you first minus the 4 to the other side, and now we square both sides, that will save us a lot of work. You could just square both sides to begin with, but that would be more messy. Because now if you square both sides, these just cancel out here, and you're left with x plus 3. Square the right-hand side, you get 16. Okay, so x equals 13. Easy as that. You also have to be careful about domains in these problems as well, because sometimes your solution will not be in the domain. So let's be careful about the domain here. And in here, x plus 3 has to be greater than or equal to 0. X has to be greater than or equal to negative 3. So we're good here because we had a domain restriction, but our solution satisfied the domain restriction. 13 is in fact greater than negative 3. Okay, let's look at another example, slightly harder example. Say we have square root of x plus 64 plus 8 equals x. And again, you could just square both sides, but if you squared both sides like this, you would have to FOIL this out, which gets messy, so it's not very wise to square both sides immediately. The wise thing to do is to get the radical by itself. So I will minus the 8 to the other side. And now that this radical is by itself, it's wise to square both sides now, because then the radical will cancel out. So now these cancel out, but we have to FOIL this out, right? So the left-hand side cancels out as x plus 64. But recall, when we square a factor, what that means is we multiply it by itself, and then we have to FOIL it out. So we have x plus 64 equals x squared minus 8x, and then minus 8x again. So minus 16x plus 64. Okay, luckily these 64s go away. Okay, I'll minus x to the other side. 0 equals x squared minus 17x. Okay. Not bad. Both of these have an x in it, so I could pull an x out. And therefore the solutions are x equals 0 or 17. Now we have to ask ourselves, is the solution in the domain? Well, let's think about the domain. We had a square root originally, so therefore we have the restriction that x plus 64 must be greater than or equal to 0. X must be greater than or equal to negative 64. And yeah, both of these numbers are greater than negative 64, so we are okay here. Okay. Let's make it slightly more complicated now. Let's have two radicals in the equation. Let's look at square root of x minus 9 plus square root of x plus 6 equals 5. Now, what we do here is I like to just have one radical by itself and then square both sides. It's still going to get messy, but if we put one radical by itself, it would be significantly less messy. Because now we square both sides and get x minus 9 on the left-hand side, but we have to FOIL out the right-hand side. So we are multiplying this factor by itself. Okay, so we FOIL it out, and we have the following: 25 minus 10 square root x plus 6 plus x plus 6. Okay, so maybe I skipped too many steps here. Let me go through this a little slower. So when we FOIL out, we do 5 times 5, 25. 5 times negative root x plus 6, so that's negative 5 root x plus 6. We do negative root x plus 6 times 5. That gives us another negative 5 root x plus 6. Okay, and then lastly we multiply these two terms, get a double negative, so positive. And we get this. So luckily the square and the radical cancel out. Okay, so we have x minus 9 on the left-hand side. 25 minus, well, these are like terms, so we can combine them. Minus 10 root x plus 6. Okay, and then plus x plus 6. Okay, so now the equation only has one square root. So again, the fastest way to solve this is to get the square root by itself on one side of the equal sign and then just square both sides. So let's get the square root by itself and everything else on the other side of the equal sign. So okay, so I'll put the 10 square root x plus 6 on the left-hand side now. Now we'll have 25 plus x plus 6, and then I'll minus the x and add the 9 to the right-hand side. Right, so all I did in this step was I took this, put it on the right-hand side, took this, put it on the left-hand side. Okay, now let's just clean it up. So on the right-hand side we have 10 square root x plus 6. The left-hand side we have, well, let's combine the like terms. We have 25 plus 6 plus 9, so what is that? Plus 6 plus 9 is 40? Yeah, 40. Plus x minus x goes away. Okay, so that's good. I could get the 10 out of there, that will be fine. So right hand side we have x plus 6, On this side we have 4. Now we could square both sides. X plus 6 equals 16. Minus the 6 over, and we get x equals 10. Okay. Is it in the domain? Right, well, what was our original domain? Our domain here is that x minus 9 is greater than or equal to 0. X plus 6 greater than or equal to 0. So x has to be bigger than 9, bigger than negative 6, so just bigger than 9. Luckily, it's a little bigger than 9, so we are okay. Yep. Okay, so that's about as hard as these ones will get, but it's not always going to be a square root, so there are other radicals. Let me give you a quick example. So a cubed root, for example, is a radical. And you may see it written differently. It could be written like this. Or in other words, we could write it like this. They mean the same thing. These are radicals as well. And you may have guessed, it's similar to what we just did, but now instead of squaring both sides, we will cube both sides, and then the cubed root and the cube will cancel out. Okay, and then we just get negative 7 cubed on the right-hand side, which, see, that's 49 times 7 is negative 3. So you won't see any examples that are too hard when we have cubed roots or anything, but a radical could be any root. Any nth root is a radical. But typically we will just be dealing with square roots, unless it's a really easy problem like this one. Okay, so that concludes the material for this lesson. Thank you for watching.